Hello students. In previous class we discussed about interference and introduction about wave optics. So based on interference phenomena we have very important topic in our syllabus, that is Newton's rings. So what is Newton's rings? So how the Newton's rings is related to the interference phenomena? So, based on interference phenomena, the condition of constructive and destructive interferences, so the formation of Newton rings will happen. The Newton's rings will appear by using plano-convex lens. So, here it is the, see, here it is the plano-convex lens, that is double plano-convex lens. Here it is, see, we can just able to see the dark and bright fringes, so here it is the center rings, the center ring, that is we can see by using a traveling microscope we can able to see the brightest and darkest circular rings. By using my traveling microscope we can see clearly the formation of rings. Okay, so what is Newton rings? The Newton rings phenomena, the phenomena of interference pattern is created by the reflection of light, reflection of light between two surfaces, a spherical surface, that is adjacent touching, that is flat surfaces. Here it is the spherical surface, and here in down, that is flat surfaces. So this phenomena or this experiment is named by Sir Isaac Newton. Sir Isaac Newton, who first studied the effect in 1717, when viewed that Newton's rings appear on a series, that is by using with the monochromatic light, that is monochromatic light, the Newton's rings appear as a series of concentric altering bright and dark rings centered at the point of contact between two surfaces. So here it is, you can see the bubble, like a bubble. This bubble in between two lenses, that point. So here it is the point which happened the formation of circular rings. Okay, with the flat surface in contact, it is one surface is slightly convex and creating the rings. So in the white light, that is rings are rainbow colored. In white light is in rainbow color because the different of wavelength to each color, the interference at the different locations. Okay, we are using monochromatic light. Okay, next. So what is the definition? The Newton's ring definition. If a plano-convex lens with its convex surface is placed on a plain glass plate, then air film is formed between the air film, what we say it is, that is bubble, that is air film between the lower surface, that is upper surface glass plate. The thickness of air film is 0. The thickness of air film is 0 at point of contact and gradually increases from the point of contact outerwards. Okay, so the monochromatic light which is allowed to fall normally on the air film, and a system of alternate bright and dark circular rings is formed in air film. So these the rings are discovered by the Newton. So that's why we are called it is Newton rings. Okay. So what is the principle of Newton rings? Newton rings are formed due to interference between the light rays reflected from the top and bottom surfaces of air film between the glass plate, that is plano convex lens. So this is the principle. So interference pattern between the two reflected top and bottom glass surfaces, and air film will be formed on the glass plate and the plano convex lens, that is known as principle of Newton rings. See, coming to experimental arrangement. So, experimental arrangement, we are using the source, the light source, that is monochromatic light, what we call it is sodium vapor lamp. So, with the angle of 45 degrees, I will show the 45 degrees angles in the experimental setup. See here it is the experimental setup, that is the construction of Newton rings. Here it is magnifying glass, here it is the traveling microscope, that is here it is the plano convex lens, and here it is air film. So see, here it is the air film, and the interference pattern for here it is the source, that is sodium vapor lamp source. It is coming to and forming on a plain glass plate, the degrees of 45 degrees, and it will partially reflected on glass plate and emerged or placed into a plano convex lens. Here it is plano convex lens. So here it is here in plano convex lens we can observe the Newton rings, the formation of rings here. Here it is the formation of rings, that is dark and bright rings. Because of destructive interference, the center ring is dark. Because of destructive interference. So here it is traveling microscope. By using traveling microscope, we can adjust the place of dark and bright fringes of Newton rings. We can find the diameter of the dark and bright fringes with the condition of minima and maxima condition. Okay, here it is. See, here it is from the F. What is F? From convex lens to source. Here it is the focal point or focal length. So this is the construction of Newton's rings. So then coming to we can discuss the theory and conditions in coming hour. So see, this is the plano convex lens. If you can see here the plano convex lens, here it is the reflection, the interference phenomena, and here it is the superimposition of light and form a dark and bright rings in the plano convex lens, and the reflected lights, that is ray 1, and the parallel ray, that is for ray 1 and ray 2, both are parallel rays. That is we already discussed the topic on the parallel thin film by reflection of interference pattern. So here is here it is no phase change, and in second ray, that is ray reflected light, there is phase change will be of pi. And constructive interference we can discuss, that is 2 mu t. Already we know that constructive interference 2t, that is thickness 2t equal to m minus 1 by 2 into lambda, and destructive interference, that is 2 into m into lambda. We can put n by placing m, we can put n also here, that is 2 mu t equal to n lambda, and 2 mu t, that is refractive index, 2 mu t equal to m minus 1 by 2 into lambda by 2. We can see the in class. See, here it is the setup, that is uh, Newton's rings experimental setup, and here it is the glass plate and plano-convex lens, sodium source, and here it is the lens and the transparent glass plate with the 45 degrees. Here it is the traveling microscope, and here it is the air film. This is the complete setup. This is the complete setup of the construction of Newton's rings. Okay. Though, see, here it is the rings are formed. Here it is the central dark fringe because of destructive interference, and after that it will be the first dark ring, first, next second, and third, fourth, fifth, up to n number of rings. Up to n number of rings we can observe in the Newton's rings. So this is the experimental arrangement. So here it is the explanation of Newton rings we already discussed. So then coming to the calculation part, the equation part of a Newton's rings. Here it is the path difference. We already know the based on parallel in thin film, that is path difference delta equal to 2 mu t cos r minus lambda by 2, that is uniform thin films. Then so for non-uniform thin films, here it is the uniform thin films, here it is uniform thin film, and here it is non-uniform thin films. So for air film, that is refractive index will be 1, and for the normal incidence r will be 0. So what will be the path difference here? Path difference will be delta equal to 2t minus lambda by 2. Next, so the path difference will be, so what will be the path difference? You can take the 2t minus lambda by 2, that will be, here it is path difference, that is equation number 1, and here it is path difference, that is equation number 2. So this is the path difference between two reflected rays in non-uniform thin films. So what is that? Here it is non-uniform thin films. So what is the special case? Why it is called a special case? That is center dark spot. We have a center dark spot, right, in Newton rings. So here it is the center point O, that is contact, it is a glass plate, lens and glass plate, and thickness of air films is approximately 0. So what will be the thickness? Is approximately 0, that is thickness is 0. So what will be the path difference? Path difference, you can substitute the t value here. So the t value will be 0 minus lambda by 2. So path difference will be delta equal to minus lambda by 2. This is the special case for central dark spot. So why central dark spot is dark? Because of destructive interference. Students, just keep it in mind, why center rings are dark. If the question arises, why center rings are dark? Because of destructive interference, the central spot is dark. Okay, right. Then so here it is that why it is dark, because of one ray will be reflected ray, and another ray will be reflected, that is both are parallel rays. Okay, so it is the center and opposite phase. Two waves are center and opposite. So then coming to theory of Newton rings. So this is the theory of Newton rings. Okay, see, if you observe, generally what we can say, the center of, we can differentiate the two parts of a circle in center, right? So here it is the center. Okay, here we can say two types, two R's. Why it is two R's? From center to and surface, and surface to lower surface. Okay, See, here it is h, e, that is the difference of day, and here it will be the thickness or distance of from 0 center to q, and that will be the r, and here it is t will be thickness. Okay, we can say that is case 1. So what is ready here? Ready, what is mean by ready? Ready is nothing but the plural form of radius. Okay, we can explaining two radiuses here. One is first R and second R. So two radius we are explaining here. Let us R will the radius of curvature. See, let us take dark located at point Q, that is PQ will be the T. See, the distance between P and Q, the thickness will be T. Then the radius of the ring, Q is the radius of the ring, Q is, and OQ, between OQ, that is the distance, that is small r. So what will be the additional path difference? What will be the additional path difference? We are explaining here, that is reflected Q is taken into account the path difference between the two reflected beams. So the two reflected beams, that is 2 mu t lambda by 2. 2t, that two thickness, two angles we are not two angles, the additional path difference 2t plus lambda by 2. So the condition for, what is the condition for bright ring? That is 2t plus lambda by 2, that equal to n lambda, and 2t equal to 2n minus 1 lambda by 2, that will be the, here it is n will be 1 and 2 3 and so on. Then what is the condition for dark? Here it is the bright ring. So what is the bright ring condition? 2t equal to 2n minus 1 into lambda by 2. And what is the condition for dark ring? That is 2t plus lambda by 2 equal to 2n plus 1 lambda by 2. That is 2t equal to n lambda. Clear? Then we can intersecting, the theorem of intersecting. So that is EP into HE. We can see the diagram, EP into HE, that equal to OE into EM. So we can simplify this. We can take the OM minus OE, that is 2R minus T. See, here it is 2R, that is 2 radius. We are calculating here 2R, and thickness of the T, that is 2R minus T. Remember here we are representing two radius. Okay, that is 2R minus T. Then from the equation, what will be the equation number 1 here? What is the equation number 1? Here it is path difference 2 mu t cos r minus lambda by 2, right? So from the equation number 1, the r into r, so it will be the t into 2rt minus, and r square will be 2rt minus t square, and t square will be 2rt is greater than t square. So t square will be neglected. Okay, then t square will be neglected. The r square will be 2rt. R square will be 2rt. Then coming to calculation of diameters of bright rings. Let us now suppose that the bright ring can be located at point Q. Therefore, the radius of nth bright ring will be given by. So, see here we can say the r square, right? Here it is rn square. Here it is the 1 square, that is first ring, that is 1th ring, and here it will be the nth ring, that is rn square equal to 2rt. Okay, we can know the condition for bright ring. Already we know the equation about bright ring, that is 2t equal to 2n minus 1 lambda by 2. Here it is the lambda by 2, that is additional path difference. Okay, so we can substitute the values. in 2t value in in Rn square equal to 2rt. So here it is the, we can take the values Rn square equal to 2n minus 1 lambda by 2 into R. We can cancel the 2 here, that is n minus 1 by 2 into lambda R, and the square will be go that side, that is root of n minus 1 by 2 into lambda R. So this is the calculation for the bright rings. Then the condition for ready of bright rings, and bright rings means what? Here it is, we are telling about the nth ring. So that, and we are calculating for the diameter for the nth ring, because that is dn square by 4, that is n minus 1 by 2 into lambda R. We can simplify this, we can get the dn, that is root of 2n minus 1 into 2 lambda R. So what will be the bright rings directly proportional to the, so dn is directly proportional to, we can split the equation, that is proportional to 1, that is root n minus 1, and the second one will be the root lambda, and third proportional will be, that is root r. So next one, the calculation of dark rings. So same in such a way that we are telling the nth ring Rn square equal to 2rt, and the condition for dark ring, that is 2t equal to n lambda, 2t equal to n lambda, that is we can know the values, that is Rn square, that is n into lambda R. We can substitute the values here. Then square will be go that side, that is root n lambda R. So this is the condition for radius of the dark rings. So we can tell the equation in nth ring, that is diameter for nth ring, dn square by 4 equal to n lambda R, and square that go that side, that 2 into root of n lambda into R, and it is directly proportional to the, see here it is root n, root lambda and root r. So this is the directly proportional to the radius of the dark rings. So what will be the applications of Newton's rings? So what will be the applications? The first one, to determine the wavelength of monochromatic light, and second one will be the determine the refractive index of given liquid. So what will the first one? So the determination of wavelength of monochromatic light source. So monochromatic light source, the experimental setup I explained about the plano-convex lens of monochromatic light source, that will be mth and nth rings, diameter for the mth and nth rings. So here it is, we have a formula based on the diagram. We can take the values on x, that is n number of rings, and in y direction, that is diameters. Okay, so here it is the slope. We can get the slope values, dm square and m value, and n and dn square. So between this and here it is n minus 1, and here is dn square minus dm square. So dm square, so the dm square we can telling the mth ring, that is dm square equal to 4m lambda R, and dn square equal to 4n lambda. So mth ring, both rings, that is mth ring and nth ring, both we are calculating. So dn square minus dm square equal to 4n lambda r minus 4m lambda r. So we can take the common lambda r, then it will be 4n minus 1 lambda r. So what will be the wavelength? We can take the wavelength here, that will be lambda equal to dn square minus dm square by 4 into n minus 1 n minus m into r into lambda. Okay, here it is 4 into n minus m into lambda r. So this is the uh, wavelength of monochromatic light of the diameter. Then next one, what will be the next condition? Here it is, determination of refractive index of given liquid. So in liquid also we are getting the mth and nth dark rings in determined it by using traveling microscope. We can find the uh, refractive index of given liquid. So we can take the small container of water or liquid, whatever it is. It can uh, pass a like interference using interference phenomena, and we can find a diameter of the given liquid. And here it is the diameters of mth ring and nth ring 2, and dn square 4 and lambda we know that already, that is dn square minus dm square, that equal to 4 into n minus m into lambda r. Then see, it is the experimental setup of refractive index of a given liquid. Okay, given liquid. So the air film, the liquid film of diameter of mth and nth dark rings determined. If manami, what we are find out here, determination of refractive index. That is why we are shifting d m dash and d n dash. Okay, so that is 4m lambda r by mu. Why it is mu? That is refractive index of a given liquid, that is refractive index for m and n. So dn square dash dm minus dn square dash. So we can simplify the equation. We'll get a equation, that is dn square dash minus dm square dash 4 lambda r into n minus m by mu. So that will be the refractive index, and we can take the we can find the refractive index, that is mu equal to dn square minus dm square by dn square dash minus dm square dash. So here it will be the calculation of refractive index, that is our formula of to calculate refractive index of given liquid of a Newton rings. I hope you get it, the all information about interference and Newton rings, and condition for minima and maxima, and dark and bright fringes, and the calculation of diameters and applications of Newton's rings. So I hope you'll get at least a bit of knowledge or piece of information. It is very useful for your reference. Thank you, students.